Now that we have a better idea of what the midpoint theorem is and how we work with it, I'd like to look at some more difficult examples. In the sketch below, PM is equal to MR and QN is equal to NR. AB is 6 centimeters and PQ is 3 centimeters. Angle A is 55 degrees and angle P2 is 75 degrees. Part A, determine the length of MN. B, determine the size of angle M1. C, if AQ is equal to QC, determine 1, the length of AP, 2, the length of BC, and 3, the size of angle B. Let's start with part A. Determine the length of MN. Let's mark MN in red. It sits in triangle PQR. So let's make this triangle blue. Now we can say in triangle PQR. Straight away, we can see that PM is equal to MR. So we can make the statement PM is equal to MR. And as our reason, we use given. We can also see that QN is equal to NR. This has been given to us in the question. So let's say QN is equal to NR. And again, we can use given as our reason. Now we know that M is the midpoint of PR and N is the midpoint of RQ, which means that PQ is parallel to MN and that MN is half the length of PQ because of the midpoint theorem. We know that PQ is 3 centimeters. So let's make a note that PQ is equal to 3 centimeters. We know this because this information has been given to us. MN is half the length of PQ. So we can see that MN must be equal to half of 3 centimeters, which means that MN must be equal to 1.5 centimeters. Let's put the length of MN into our diagram. We also know that MN is parallel to PQ. So let's put a blue arrow on line PQ and on line MN. Let's make the diagram black again. And now we can move on to part B. Determine the size of angle M1. We have just found that MN is parallel to PQ, and parallel lines can help us find angle relationships. We know that PQ is parallel to MN, but MN sits on the straight line BMNC, which means that PQ is parallel to BC. So let's make our parallel lines blue. Angle M1 sits over here to the left of line PM. So let's make this our transversal line. Let's make it purple. Now we have a Z shape. So let's make some notes. We know that MN is parallel to PQ. We've already proven this. So as our reason, we say proven above. Therefore, we also know that the longer line BC is also parallel to PQ. And as our reason, we say MN lies on side BC. The 75-degree angle up here at P and angle M1 both sit inside the Z shape. So they are alternative angles, which means they are equal. So now we know that angle M1 must be equal to 75 degrees. And as our reason, we say alternative angles. Let's put 75 degrees into our diagram for angle M1, and we can make our diagram black again. Now we can move on to part C. If AQ is equal to QC, determine the length of AP. The question tells us that AQ is equal to QC. So let's put 3 green lines on AQ and 3 green lines on QC to show that they're equal. Now AP sits on side AB, which is 6 centimeters long. AB is the side of the larger triangle ABC. So let's make this triangle red. To find the length of AP, we need to prove that P is the midpoint of AB. So now we can say in triangle ABC, we now know that AQ is equal to QC because this information has been given to us. We also have found that PQ is parallel to BC. We don't have to prove this again. So as our reason, we say proven above. Now we know that Q is the midpoint of AC, and we know that PQ is parallel to BC. So according to the midpoint theorem, we now know that AP is equal to PB, and as our reason, we use converse midpoint theorem. We also know that AP is equal to half of AB. We know that AB is 6 centimeters long because this information has been given to us in the diagram. So if AP is half the length of AB, we can say AP is equal to half of 6 centimeters, which means that AP must be 3 centimeters long. Let's put 3 centimeters into our diagram. We know that AP is equal to PB, which means that PB is also 3 centimeters. So let's put this into our diagram as well. Now we can make our diagram black again, and we can move on to part 2. Determine the length of BC. Now BC is a side of the larger triangle ABC. So let's make it red. Now let's look at the information we have in triangle ABC. We know that AQ is equal to QC. So we can make the note that AQ is equal to QC. This information has been given to us in the question. So as our reason, we say given. We also know that AP, make a note over here, is equal to the length of PB. We've already proved this, so as our reason, we say proven above. Now we know that P is the midpoint of AB and Q is the midpoint of AC. According to the midpoint theorem, if we have a line drawn between two midpoints, P and Q, it is parallel to the third side, BC, and half the length. So we now know that PQ is equal to half the length of side BC. And as our reason, we say midpoint theorem. If PQ is equal to half of BC, then if we multiply both sides by 2, we see that 2 multiplied by PQ gives us the length of BC. This is what we're looking for. We know that PQ is 3 centimeters long, so let's make a note that PQ is equal to 3 centimeters. We know this because this information has been given to us in the question. BC is equal to twice the length of PQ. And we know that PQ is 3 centimeters, which means that BC is equal to 2 multiplied by 3, which means the length of BC is 6 centimeters. Now let's draw a line just under BC, and we can make a note the length of BC is 6 centimeters. Let's make our diagram black again, and we can move on to part 3. Determine the size of angle B. Angle B sits at vertex B over here between side AB, let's make it red, and side BC, let's make it red as well. We can use the information a question gives us, as well as the answers we've already found in earlier parts to help us. So let's see what else we know about AB and BC. We know that AB is 6 centimeters. So make a note, AB is equal to 6 centimeters. Because this information has been given to us, we've also just found that BC is also 6 centimeters. We don't have to prove this again, so we use proven above as our reason. AB is the same length as BC, which means that ABC is an isosceles triangle. It has 2 equal sides, which means it has 2 equal angles. Angle A is 55 degrees, which means that angle C is also 55 degrees. We can say angle C is equal to angle A, and these are both equal to 55 degrees. And as our reason, they are the angles that lie opposite the equal sides. Now we have a 55-degree angle, 55-degree angle at C, and an unknown angle at B. But we know that if we were to add the 3 interior angles together, we would get a total of 180 degrees. And we can use this to find the size of angle B. So we can say angle B is equal to the total of 180 degrees minus 55 degrees for angle A minus 55 degrees for angle C. And as our reason, we say the interior angles of a triangle. Now we can see that angle B is equal to 180 degrees. 55 plus 55 gives us 110. So we say minus 110 degrees, which means that angle B is equal to 70 degrees.